Hi everyone, welcome to this module. I'm Hardik here. You can ask me any questions if you have. If you are stuck with any particular topic in the course, and in general, if you have other questions related to this particular topic in this particular syllabus, or maybe relevant questions to the same. Yeah, hi Thomas, good evening. Yeah, I don't know whose research plan you're asking, Thomas. Is it mine? Uh, but yeah, if you are asking about future research plans in this particular area, what we do is we have fabricated few bioresorbable sensors, and those sensors we are using for rat model, animal model, to acquire the ECOG signals. And ECOG stands for electrocardiography. This can be used for epilepsy. It can be used for stroke. Uh, Same way, we have also designed a flexible sensor that you can implant in rat's brain. Is more like brain surface stimulation. There is a deep brain stimulation, as you know. This is for Parkinson disease. So we want to use the electrode and see if we can help the people with Parkinson. That is a bigger goal. But to start with, we are using rodent models. Other things that are part of this particular plan is to develop a probe, and that probe will be integrated with MEMS-based sensors that is used to delineate the normal from cancer. Particularly, we are focusing on brain cancer, and as you know, brain cancer is glioblastoma, meningioma, right? And we are also focusing on integrating some ultrasound transducers along with NIR and photoacoustic with here thermal modulation for breast cancer, in vivo breast cancer delineation. So these are few of the future research plan which few of my students are working on. You'll be looking at a few of the papers soon coming out of the laboratory. We have published few in this next 3 4 months. You will see many more papers coming in this direction. Yeah, so Thomas, your question is valid. Whether I'll be focusing on non-invasive or minimally invasive, what you say semi-invasive is called minimally invasive techniques. So it depends on application. Okay, not all the techniques should be non-invasive. Neither every technique can be minimally invasive, right? Depends. So, for example, these force sensing technologies that we use for atrial fibrillation, that we integrate this force sensor to the catheters, for that, you have to operate the patient by inserting the catheter and burning or ablating that particular region in the heart, isn't it? So, for that, you have to have minimally invasive technology. But if you're talking about screening of breast cancer, for example, or screening of COVID patients, in fact, right? So in that you can use a breath signature to understand whether certain biomarkers or signature is typical signatures are there for certain disease or not. So again, depending on application, you have to change the way and process to fabricate these devices. But more than what kind of techniques we'll use, what are the applications that we are working on is more important for me. Finally, our lab is focused on developing solutions for people, not only people of our country but entire world. But firstly, for our country, the solution should be viable, should be affordable, and it should reach to common man. Right. So that is my top priority. But along with that, we do research which is accepted by anyone and everyone in science community. Right. So the quality of research is not compromised when you say a device is affordable. But rather than saying just minimally invasive or non-invasive is not really a right way to differentiate the thought process. Yeah. Sorry. But yeah, Thomas, it was really interesting question. So I hope I have answered few things which may be valid, right, for you. Again, it's a perception how we how we listen to everyone and how we perceive the things. So, but great question, Thomas. So let me come to next question asked by Vaishali. Vaishali is asking, is there any fabrication labs available in Maharashtra? Yes, of course. If you go to IIT Bombay, Vaishali, they are very nice fab lab. You can utilize that fab lab for fabricating devices. How fabrication can be proceeded in Maharashtra, or is there any facility? I think I already answered this. That you can approach to professors, faculty working in the area of fabrication in a particular institute. I have given example of IIT Bombay. When you approach with the right problem, and I am sure that people over there will help you out. There is also a program called INUP, through which you can learn and give a sample or a device process to the FTs in a fab lab. And probably, I am not too sure, but probably they do it for free. All right, so that is how you can utilize the fabrication facility in fab labs in IISc as well. Right, INUP program is there. So just type down INUP and you will find it out. IIT Bombay, IISc, IIT Delhi, probably. Just look into that. Vaishal. So let me just again finish what I started with answering about Thomas' question. He also asked about optical spectroscopy. So Thomas, you cannot say optical spectroscopy is just a non-invasive technique, because if I want to measure the NIR, I use NIR, right? And if I integrate this NIR in a probe, and that probe is used within the body, that means it's in vivo. Then even though the sensors that are optical, right? So because they're integrated with the probe, it becomes minimally invasive. So non-invasive is not really like optical spectroscopy. Okay. All right. So let me, yeah, no worries, guys. I am here to answer your queries if I can. Okay. There are a lot of things that I also don't know, and many people who teaches you a certain course, there are some interesting questions that we as a faculty don't know, and we have to find it out and get back to you. Okay. So it goes both ways. So no worries, no need to thank me. It's my duty. So let me take another example from Vaishali. Vaishali is asking how we can decide on sensing films. Okay. So it is very easy, because there are plenty of literature which shows what kind of sensing film you have to use for certain VOCs. All right, VOC stands for volatile organic compounds, right? I don't know whether this lecture is finished or not, but if it is already done and if you have understood what I taught in the lecture, right, about gas sensors, you will see that VOCs are examples of VOCs are acetone, methanol, ethanol, butanol, IPA, kerosene, petrol, right? Of course, we don't exert kerosene and petrol, but breath signature is very important. So for that particular VOC that you are targeting, there are sensing film which are more sensitive to one rather than second. And the why people go for nanostructure material, so mostly people use metal oxide semiconductors, as you already know, it's called MOS gas sensors. Now if you can deposit thin film and you can also work on nanostructure materials. The advantage of nanostructure material would be the high surface to volume ratio. That means that the sensing gas has more area, right, to interact, and that's why more change in resistance. So the sensors which have sensing film, which is nanostructure in nature, are more sensitive compared to those sensors which has thin film, thin sensing film as its material. Now, within sensing film, what kind of sensing films you can use, right? So you can use zinc oxide, you can use indium oxide, you can use indium tin oxide, you can use tungsten oxide, and there are plethora of different sensing materials that you can choose from depending on application. So that's what my submission is. Because each only single sensor may not be sensitive as well as selective both, particularly selective, it's very difficult, right? So that's why what people do is they start integrating array of sensors, right, onto a single chip. And when you have array of sensors onto a single chip, it is functioning similar like nose. But when we say nose is connected with your brain, right, olfactory lobe, and then it processes in the brain, then it delineates which kind of smell, right? So that's why you have to have train this particular array of sensors and connect it with the proper machine learning algorithm, and then train the algorithm for given set of VOCs and its concentration. And then when you have enough training, you can test it for unknown samples, and if probably the training set is good, then you will get a proper result. So it's a long process, but selecting sensing material is depending on how good your literature survey is and the application, of course. Yeah, good evening, Kavita. Yeah, so I think if you don't have any questions, okay, you have something. Okay, great. How can we analyze of maximum sensing area can be expected on rectangular and circular sensor? Okay, I think that is more on a simulation aspect. Again, depending on the area of sensors, how many sensors you have to integrate together, we can understand the how to place the sensor. But more on a console simulation, you can understand that what kind of proper design would be, right? And also it depends on the again the whether the portability of a sensor is there or not. If you have seen gas chromatography, you will understand the way it works, right? We are totally opposite to gas chromatography because we are using sensor here. If you fabricate sensor, the sensing area would be different than using commercial sensor. So maximum sensing area on a interdigital electrode. It can be circular or rectangular, doesn't matter. I think it's more like how good your sensor sensing area is. All right. The second thing that you have to understand is it should properly cover the interdigitated electrodes or the electrodes below it or over it. There are multiple ways of fabricating. If you have seen, one is where the substrate is there is a heater, and then there is an insulator on which there are interdigitated electrodes, right? Second is that there is a heater insulator on the sensing layer over which there is the interdigitated electrodes. So uh, people use different ways to make sure that the maximum area of the sensing layer faces towards the gas, right? So there is maximum interaction. So I have seen many sensors which are circular in nature as well as rectangular. I don't think that should affect a lot in terms of improving sensitivity or not. Right? The sensitivity depends on the sensing layer and the structure of the sensing layer. That means the if you go for nanostructure, it is better compared to sensor. So the concept remains same, but the dimensions would change, right? People say he knows, and then it's very difficult to actually fabricate nose along with brain, which is so tiny. But a good amount of research is going on in this direction. People are trying different applications. It's a very exciting technology to work with. But if you still have further questions and if you are stuck somewhere, please let us know. I'll reply back to you via email. Okay. Yeah, if you tell me exactly, Vaishali, what is your problem where you are stuck, and you send me an email, I'll get back to you with that particular answer. Okay. We can do multiple ways, but the again, if one single sensor is different than multiple sensors. So I had to understand in detail what kind of sensors you are developing. Feel free to send me an email. We can have in-depth discussion for the problem that you are stuck on, and with best possible things and with best of my abilities, right? I'll help you out to identify the solution for the same. And you all know my email ID. It's very simple, right? To you can address to me. Again, just don't say hi, hello. Just if it's a really important question, then you can always shoot me an email, right, and ask me a question, and I'll generally I reply back to you. If you have done previously, I have replied. In case if I have not replied, please remind me and send a soft reminder, and I'll reply. Okay. So sjpndy@sif. Yeah, this is my email ID. No, I never said any third fabrication institute, Vaishali. IIT Bombay and IISc. That's what I said. Other than IIT Bombay and IISc, where else it is there? I think in NITs it is there. For example, NIT Trichy, hopefully, I think they have one. Uh, and then IIT Madras has all the mostly IIT old IITs they have it. IIT Delhi has it. Uh, NITs, which NITs particularly have it, I have little bit less information about that. But again, if you send me an email, I can find it out and let you know. But in bits and pieces, people have the system. Like they have either thermal evaporation, or somebody would have a sputtering, somebody would have lithography, and somebody would have something else like say RI. But everything under one roof is very difficult. It's a costly affair, and it's a huge infrastructure cost that goes behind developing such a clean room facility, and that's why all IITs they have the clean room facilities, but you will see that a lot of institutes they may not have clean room facilities. So I have to see to get proper information for other institutes other than IITs, which particular institute in Maharashtra, if you are asking for Maharashtra, have those facilities. Okay. All right. So Thomas is asking amount of USC Excel by different persons will be different. what approach can be enough to decide on optimal threshold level? No, no, no. Amount of VOCs, of course, it will be different, right? But the volume that you are measuring from every person should be similar, because first is you have to have normative data, right? Data obtained from subjects who are not having any particular disease, right? And then you have a base value. With respect to that, when somebody suffering from particular disease, if you take those signatures, it will be different. Now, the sensitivity, that's what VOCs of a different person will be different. No, it will be different, but not drastically different. For example, if somebody is suffering from diabetes and particularly high level of glucose, then it comes to ketosis. So ketone body generates, because of which the smell becomes sweeter, and those the breath signature of people suffering from ketosis, their acetone concentration is significantly higher compared to other VOCs. So, and significantly higher doesn't mean it shoots to 100 ppm. It's just like 1 ppm. Most of the VOCs are in ppb range, parts per billion. Only few goes to ppm for that particular disease. So that's how it is. It's not like every person will have a different level of VOCs. Mostly the breath signature remains same, but the volume would change, and we had to do a lot of study, because we can body mass index probably would affect. We have to have a huge set of normative data, again, not just from one region but from multiple regions, right, to really understand that it is same or not, and then only we should try with a disease subjects, right. So no, and then another point is, there are already literature which says that if a person is suffering from certain disease, these are the VOCs which will be higher in concentration compared to normal subjects. So you need to understand that what application you are thinking of, Thomas. Also, you need to also understand the effect of humidity, right? Effect of temperature. There will be CO2. CO2 is in very high concentration compared to other VOCs, right? So a lot of things comes into play when you develop a e-nose. It's not so easy and simple technology to develop. Not really. All Q1 journals, quartile 1 journals, they accept sensor fabrication, in some cases simulation, in some cases modeling and results, and of course you have to justify your results. That comes under the discussion portion. Partial results, I'm not too sure. No, I have not seen, right, at least for good journals. Okay. So if I say that I will measure this set of VOCs and there is an application for this, but I also fabricated an array of sensors, have tested those VOCs, have understood the effect of humidity, this and that, and these are the results, and I can say with surety that for 10 subjects I can find this, or at least if I don't have subjects, then I can understand the concentration of VOCs and I have tested it, and my sensor is showing so and so sensitivity and selectivity. If that is the case, your paper can be probably accepted. Again, depends on the quality of how you write the paper. Also, repeatability is another issue. Response time is another issue. So, for a given sensor, there are many parameters that one has to see, not just fabrication, but also results of the sensor itself, and sensor when there is a presence of one gas and presence of many gases. So, how selective it is, right? What is the performance? So, this all things has to be included in a paper before, if you really want to submit to a good journal, quartile one journals. Right? But again, partial for you would be uh, different in terms of, until I see the data, it's very difficult to tell. Right? So what exactly partial results means. So because sometimes people think that the results are not enough, but actually it is more than enough. In some cases, they see that there are a lot of results, but it is not really enough for publishing. So depends. But I have not seen, at least I have not seen any journal with partial results published. How can we go for more than one research paper on the same research topic like sensor development? You see, sensor development itself is a research, right? So you can use bulk micromachining, you can use surface micromachining, you can use bulk plus surface micromachining. One of the papers, I don't know whether I have taken the topic or not, but if in gas sensor, there are ways to create the sensor with a mechanical stability. If you create a sensor on a 100 micron diaphragm, or you have a diaphragm of 2 microns, right? And you will see that the temperature, the power required to receive a particular, reach a particular temperature in 2 micron diaphragm versus 100 micron diaphragm would be significantly lower, right? Because we have to only heat 2 microns. In that case, you have to heat 100 microns. But in both the cases, you are playing with a mechanical stability. The mechanical stability is not that great like oxidized or like original silicon wafer. Suppose you take 4-inch silicon wafer, and 4-inch silicon wafer has 500 micron thickness. Now, if you bulk micro machine and make it 100 micron, or you do bulk plus surface and make it 2 micron, right? Then the mechanical stability is lost. So what we need to do? We have to come up with a new idea such that the mechanical stability is retained, but still the power required to heat the temperature, heat the heater, right, or to reach the temperature reduces significantly. How you can do that? So if I give an example, if I give you an example, if you could take a silicon, oxidized silicon wafer, remove oxide from the center. All right. So what you will see silicon wafer. Now you add silicon wafer for 5 micron pit, deposit zinc oxide, or sorry, silicon dioxide, do CMP, and the remaining process is same, like heater, interdigital electrode, and sensing layer. What will happen, because you have created this 5 micron pit which is filled with silicon dioxide, the heat loss from the backside of the silicon will be extremely low, and that's why you can retain the mechanical stability, but you will see that the power required to reach a particular temperature would be reduced significantly. That itself is a novelty that you can bring on. The second part is when you change the sensing material, then also, and the application also, so that way you can have many publications in this domain. Yeah, that is not really increase sensing area in a way, because you have more interdigital electrodes. The width is extremely small, so that sensing area would kind of increase, and then that's why the IDs with significantly lower width and spacing between each finger are considered or are opted for a better contact, right, than just using two different fingers, like just two finger electrode versus interdigital electrodes. Interdigital electrodes are used quite frequently, so the overall sensitivity increases. All right, so I'm hoping that you don't have any other questions for now, but if you have, do ask me right now. And if you don't have questions, then I wish you all the best for your last leg, right? That you to run hard and finish it up, right? Understand the technologies. I'm very happy that at least few of you are utilizing it for your research work, right? Very important to learn the subject, but also apply it somewhere. So that's a great feat. Uh, Try your best, right? Focus and finish up the lecture, right? And the syllabus, and score well, right? But scoring, do not always get into wrong notion that the person who scores more is more intelligent, right? It is not literally true. Learn more, right? Understand more, absorb more, right? And try to utilize it, implement it in your research, right? That's the best way to learn any subject. All right, so I'm assuming that you don't have any questions, so we will stop the session now. And if you have anything to ask, feel free to send an email to me, and I'll be very happy to respond to your email. Thank you very much.